Welcome to the deep dive. We take your sources, cut through all that noise, and really pull out the essential insights. Our goal, to give you that aha moment, basically, help you get informed without drowning in information. Today, we're looking at something pretty foundational in computer programming. It's a shift that really changed how developers write software. It took a language, Java, that some might have seen as a bit bulky, maybe, and made it feel much sleeker, more powerful. We're talking about Java Lambda Expressions, and our source for this is Understanding Java Lambda Expressions, a beginner's guide. So we're going to try and strip away the really technical jargon here and just get to why this one feature is such a big deal in modern programming. Even if you've never written code yourself, this is about understanding a real shift in, well, how we tell computers what to do. Okay, so let's just dive right in. What are these Java Lambda expressions exactly? Our source mentions they showed up with Java 8, which was what, back in 2014?
That's right, 2014.
And at its core, it's described as just a way to write, like, really short bits of code that does one specific thing without needing a whole separate class or full method structure.
Exactly. Think of it like a very quick instruction.
Yeah, the source uses this analogy like a quick note with instructions, something simple like sort this list alphabetically.
Or find all the items bigger than 50. Just a single, concise command.
So you can just pass that little command around in your program.
Precisely. You pass it to where you need that action done. No need for all the usual ceremony.
And this is part of functional programming in Java.
Yes, that's a key aspect.
Yeah.
Functional programming is really about focusing on functions, these self-contained actions, to process data. The idea is to make things simpler, more predictable. You put data in, you get a result out with fewer side effects messing things up. Lambdas are perfect for that style.
Okay, that makes sense. Predictable is good in programming, I imagine.
Oh, absolutely.
So if Java was already so popular, why did it suddenly need lambdas? What was the problem they were trying to fix?
That's a really good question. It gets to the why behind it. You see, before Lambdas, Java was very, very focused on what's called object-oriented programming, or OOP.
Right.
And OOP is great. It's powerful.
Mm.
But for simple tasks, it often meant, well, a lot of extra work. Like the source mentions, just to sort a list, you might have had to write a whole separate little class with its own method inside just for that one small sorting job.
Wow, okay. That sounds cumbersome.
It could be. It led to what developers call boilerplate code.
Boilerplate.
Yeah, like the same repetitive setup code you write over and over again for common tasks. Imagine filling out the same header on different forms all the time. It's necessary, but tedious.
Gotcha. So lots of extra lines of code for simple things.
Exactly. And that made code longer, sometimes harder to read, and definitely slower to write. So Lambdas came in to tackle a few specific pain points. First, that bulky code. Lambdas let you define a task in maybe just one line, cuts down the clutter significantly. Second, the repetitive boilerplate. Instead of writing similar sorting or filtering logic again and again, you use a concise Lambda, more reusable.
Makes sense.
Third, it really helps with readability. Sometimes, with all the extra classes and methods, it was hard to see the core logic. A Lambda focuses right on the what action needs to happen, much clearer.
Right, the intent becomes obvious.
Exactly. Then there was data processing. Working with lists, sets, any collection of data could be quite tedious using traditional loops. Lambdas, especially with Java streams.
Ah, streams, yeah.
Streams act like assembly lines for data. Lambdas plug right into those streams, making filtering, transforming, sorting data incredibly smooth, like a chain of operations.
Okay, like snapping Lego blocks together.
Sort of, yeah. And finally, parallel processing. Getting tasks to run at the same time using multiple cores on a modern CPU.
Yeah.
They used to be pretty complex to set up reliably. Lambdas, because they're typically self-contained, make it much easier to write code that can be parallelized safely. Huge performance boost for big data tasks.
So it sounds like a fundamental shift from telling the computer every single step of how to do something to just saying what you want done.
That's a great way to put it.
And for you, the listener, even if you're not a developer, this matters because it means software can potentially be built faster, cleaner, and handle data more efficiently. Think about apps processing photos or websites handling lots of user requests. This helps make that possible. Okay, so we know why they were needed, but how do they actually work? What's the mechanism that makes them so concise?
Yeah, the how is quite clever, actually. The core idea, as we said, is defining that function compactly. No need for the full method definition with its name, return type, all that stuff. You just specify the input parameters, an arrow, and then the action. Like X metex X.
Meaning take a number x and return x squared.
Exactly that simple.
Yeah.
And the way Java knows what this little snippet means is through something called a functional interface.
Functional interface. Okay, what's that? Sounds a bit technical.
It does, but the concept is straightforward. Think of a functional interface as like a contract or a template for a single specific type of task. It basically says, I need a function that takes, say, one integer and returns a Boolean. Or I need something that takes two strings and returns an integer. Just one abstract method to implement.
So it defines the shape of the job.
Precisely. It defines the shape. And a Lambda expression is then the perfect compact implementation that fits that shape. It fills in the details of how to do that specific job defined by the interface.
Ah, I see. So the interface is the job opening and the Lambda is the perfect candidate that just shows up and does the work.
That's a brilliant analogy, yes.
Yeah.
And because the Lambda fits that interface contract, you can pass it around. You can give it to a method that expects that type of function.
Like giving the sorting instruction directly to the list's sort method.
Exactly. You tell the list, here's how I want you to compare items using a Lambda. Or you tell a stream, filter out items using this condition. Again, with a Lambda.
And you mentioned streams earlier. How do they work together so well?
Yeah, streams are designed for this. Think of a stream as a flow of data, like items on a conveyor belt. You can attach lambdas at different points on the belt to perform actions. Filter items out, change each item somehow, sort them, collect the results. They chain together beautifully.
Makes processing a whole sequence of data much easier, I bet.
Immensely. And another key point is that lambdas are generally designed to have no side effects.
Meaning
Meaning they usually just take input and produce output without changing other things elsewhere in the program. This makes them really predictable and reliable, easier to reason about, easier to test, and safer for things like parallel processing.
okay, predictability again seems crucial.
It really is in software development.
So let's pull this all together. If we look at the big picture, what are the core advantages? What's the real-world impact of Java adopting lambdas?
Well, connecting it all up, the advantages are pretty significant. We've touched on them, but let's recap. First, undeniably, shorter code. Fewer lines means less typing, faster development, often easier maintenance.
Right. Less code, less potential for bugs, too.
Often, yes.
Nice.
Which leads to the second point, easier to understand. By focusing on the what, the intent of the code becomes clearer. Readability is huge. Third, they're more reusable. That same little sorting lambda, you could potentially use it in multiple places without copy-pasting logic.
Makes sense.
Fourth, as we discussed, better data processing. The synergy with streams is a game changer for handling collections efficiently. Filtering, mapping, reducing data becomes much more straightforward.
Crucial for modern apps dealing with lots of data.
Absolutely. Fifth, that's support for parallel tasks, making it easier to leverage multi-core processors for better performance, especially with large data sets. Think big data analytics, scientific computing.
Yeah, helps speed things up.
Definitely. And sixth, tying back to your point, generally fewer bugs. Simplicity, predictability, avoiding side effects, it all contributes to more reliable software.
Okay. And overall?
Overall, it makes Java feel more modern and flexible. It brought in functional programming ideas, making it more expressive, kind of aligning it better with languages like, say, Python or Scala in certain aspects, while keeping its own strengths. It adapted Java for modern needs, complex web apps, data analysis pipelines, Android development.
So what this really means for you, the listener, is that the tools developers use are evolving to be more powerful and efficient. This allows for building more complex, responsive, and reliable software faster, which ultimately benefits everyone using that software.
Precisely. It was a necessary evolution for the language.
Okay, practical time. For listeners who might be curious, maybe even starting to learn programming, or just want to understand this better, any tips for getting started with Lambdas? How do you dip your toes in?
Good question. My main advice is always start simple.
Light.
Like the examples in the source. Take a list of numbers, try filtering out the even ones using a lambda, or sort a list of names alphabetically. See the difference compared to the older way if you know it? That comparison makes the benefit really clear.
Focus on those small, concrete wins first.
Exactly. And keep that analogy in mind. It's just a quick instruction you're giving to the collection. Keep only the names starting with A. Think simple.
And what about using them with streams?
Definitely practice with streams soon after. Maybe take a list, filter it, then transform the remaining items, then maybe sort them, chain a few simple lambdas together. That's where you really start to see the fluency and power.
Right, building up the complexity gradually. Are there any common mistakes or pitfalls for beginners?
Well, one thing is Don't feel you have to use a Lambda everywhere. Sometimes a traditional named method is actually clearer, especially if the logic is complex or needs to be reused in a very specific way. Use Lambdas where they genuinely improve clarity and conciseness, not just because you can.
So use them judiciously.
Yes, exactly. And the other thing is just experiment. Create small lists, small data sets, and just play around. Try different Lambda syntaxes. Hands-on is really the best way to get comfortable.
Solid advice. So ultimately, Lambda expressions are a surprisingly accessible way for even beginners to write Java code that's shorter, clearer, and, yeah, more powerful. It's about doing more with less code.
That sums it up nicely.
And that brings us toward the end of this deep dive on Java Lambda expressions. We've seen how this one feature really helped Java evolve, moving from sometimes bulky code to something much more concise and modern, making it better at handling complex data efficiently. It's a fantastic example of how programming languages adapt and improve over time.
It really is. And, that whole shift we talked about, moving from detailing how the computer should perform every little step to more declaratively stating what you want achieved,
Hmm.
it makes me wonder.
Oh.
Hey, it poses an interesting question perhaps for you listening. Where else in your life or maybe in your work could you benefit from that same shift? Moving focus away from getting bogged down in the intricate how-to steps and instead putting more energy into clearly defining what the actual goal or outcome you need.
Hmm. That's definitely something to think about, focusing on the what's over the how. A great provocative thought to end on. We hope this deep dive has given you some valuable insights and maybe sparked some curiosity to explore these ideas further. Thanks so much for joining us on the deep dive.